Alright, let's talk about how I can turn this into this motor principle into an actual electric motor. We're going to be talking about a DC motor, meaning the current is moving in one direction only. In AC, it would be moving back and forth in my wire, but here it's only moving in one direction. So I have a diagram here. Let's take a look. I've got a magnet north-south. I've got a battery, a cell. Current is going this way. Rheostat is a variable resistor, so I can make the resistance more or less. That would change how much current is flowing here. So this current goes this way through this. There's a little circle here, just so we're clear. Whoops. I'm going to draw it over here because we'll be talking about it later. I've got a little commutator. It's a circle, you'll see, but at the top and the bottom there's a space where so it's not a complete circle. And I've got wires. I've got a wire here, a square of wire, and if you notice that this wire comes down and it's actually touching the inside of this circle, and it's free to rotate around and touch the circle as it rotates. So wire, and then the current comes this way and through and back to the cell. Okay, so I'm interested, let's talk about XW here, this part of the wire. This is a wire carrying current in a magnet. There will be a force acting on this part of the wire here. What direction is that force? Get out your right hand. Your fingers should be pointing from north. Looking at this picture, your fingers should be pointing from north to south. Yes? The current is going away from you or into the page. Yes? And therefore the force should be coming out of the palm of my hand, which is pointing right now down. If you have your right hand out, and you should have your right hand out in front of you trying to recreate this, you would hopefully see that the palm of your hand is pointing down. So XY is going down. Now the current comes along here. Now I'm looking at YZ. Sorry, XW, I misspoke there. Now I'm talking about YZ here. The current, the magnetic field is still pointing in this direction. The north and south haven't changed. But now the current is coming towards you. So your hand has to be, your palm is facing up, and so the force is pointing up, and the force on this part of the wire would be up. So what's this wire going to do if it doesn't have a lot of friction or anything to slow it down? This thing's going to start to spin. Currently it's like this. Yes? If I'm looking at it kind of from this direction, it's flat, and we decided that this side is going to be forced up and this side is going to be forced down, and this thing's going to start to spin. And it's going to spin, it's going to accelerate, and it's going to accelerate until it gets to here. Because remember, this side of the wire, this part right here, is being forced up. So after it gets to the, let's say it's 12 o'clock, 6 o'clock position, if it tries to go further on, this side would once again be pushed up, and this side would once again be pushed down, and it kind of gets stuck here. It starts to spin, it goes, it gets stuck in this position. It might continue to rotate for a little bit in terms of, but friction will eventually slow this thing down, and it's going to get basically stuck, or we're not going to get complete rotation. And if I want to have a motor, I want this thing to keep moving. I don't want it to get or do half turns or get stuck in an upright position. So how can I get this thing after it reaches 90 degrees or up and down to keep going? Well, there's only two factors that are producing the force. It's the magnet or it's the current. Yes? Now let's talk about the magnet first. to get this thing to keep spinning down, I would need to suddenly change where north and south were. I would need to have them flip spots really quick. Every half turn, these things would have to flip spots, and that is not really practical. Yes? So the other thing that I might try to change is the current, the direction of the current flowing. So currently in WX, the current is flowing this way. When it gets to the 12 o'clock, 6 o'clock position, if I could get it to suddenly go the other way, then it would be forced down. So let's talk about that. So we know this part's going to be forced up, this part's going to be forced down, it's going to get to here, yes? Now, at this point, instead of this part of the top being forced up still, I want it now to be forced down, and I want this part, instead of being forced down, I want it to be forced up. I want this to keep going. So the current helps me do this, the current change, and that's where this commutator comes into play. I have another little diagram of a commutator. Yes? So here's the commutator. Now in this diagram right here, the brushes are on the outside. On ours, this wire is touching the inside, but it's the same thing. So I have this thing hooked up to plus and this thing hooked up to minus, let's say, in a battery. Yes? And right now this thing is touching this side and the negative is touching this side. This commutator starts to spin. Yes? So right now it's touching plus, it's touching plus, it's touching plus. Eventually, as this thing spins, both this and this guy right here will be touching the space, right? They won't be touching the plus or the minus, they'll be just touching space. And then as it continues to spin, this guy they'll switch sides. So right now this guy is touching plus, but as it continues to spin over to this side, soon this piece right here, this half of the circle, will now be touching the negative side, and I will have switched the direction of the current. I have another little diagram here looking at it straight on. Right now this guy's attached to red. This guy, well, it's on the space. I don't like the fact that they've made this brush so big so it touches both. I would prefer that it just be smaller. So, but I got to do what I got to do with this diagram right here. So as this commutator spins, let's say that this thing starts to spin right now, soon this guy, this half, will be touching red and this half will be touching blue. But as it continues to spin, soon this guy will be touching blue and this guy will be touching red. And if we say red is plus and blue is minus, we see that each side is going to be connected to a different terminal of the battery, and the electricity, the direction of the electricity, switches back and forth. So currently the current is flowing this way, but when this square of wire is up and down, the current will switch direction, and then it will be forced down, and then when it gets to vertical position again, the current will switch again, and I get constantly the current switching directions, which makes this thing continue to want to spin, as opposed to just getting stuck in this position. It gets forced up, it gets forced down, it gets forced up, it gets forced down, it gets forced up, it gets forced down, as this loop of wire spins. They started to make some changes to these motors. I soon realized that if I put, instead of just a single wire, if we put a loop or a solenoid, they got a better, more force happening, works better. Also too, they realize, hey, let's put iron in the middle of this solenoid, and that will make it work even better. making more current doesn't actually make this much better, because it starts to get really hot. So that's not a workable, functionable way to make this better. So they don't try to put more current in on this. So there's my little video about how a DC motor works. Oh, AC motors. Let's just briefly say it. So I'm using DC current. The current only goes in one direction. And then what did you? That screwed us over, because this square of wire would eventually get caught in the up and down position. And so what did we do? We had to make the current go in one direction and then in the other direction, and then we had to keep having it flip back and forth using this commutator. But hey, AC current, you know what it does? It goes back and forth all by itself. So it solves this problem. When I'm using AC current, I do not need a commutator, because the current itself is flipping back and forth. If you asked yourself, what the hell do I need AC current? Like, what is current that goes back and forth? Well, what purpose is that? Why don't I just have current that's always going in one direction? This is one of the two reasons, is that motors won't need a commutator anymore. And everybody who, every electrical engineer who builds a product that will run on this electric motor idea knows exactly how often the current switches directions in the wire, and so they know its frequency, and therefore they build their devices to know exactly when this thing is going to start flipping directions. So yeah, this is one of the two reasons why we use AC current. The other reason we'll learn soon enough in class.